Thanks for
Is
inviting.
it yeah, you're in Mumbai right now? Is it raining
I
heavily
came
there
to
or not
my
so much?
hometown. I came to my hometown, Kerala. I'll be
Okay.
back mid of next
Ah,
week. Mid of. Yeah,
okay, okay, okay. So you're not in the rain thing right
yeah,
now.
I'm not in middle of rain. Yeah, Kerala too been
Yeah.
raining last week. Now it's okay.
Okay, okay.
Maybe this
Yeah.
west coastal regions we comes the first. No, if any
Yeah, yeah.
uh, yeah
Yes.
issues like rain, Cochin experience the first, and then it comes to Goa and Mumbai in
Goa,
that.
right, right. But return monsoon doesn't go from there, right? It crosses through Tamil Nadu, or you do get
Return
return
monsoon is
monsoon as well.
northeast, I believe. Northeast
North.
monsoon. Yeah, this is the
Yeah, yeah,
southwest. Start from south
yeah.
and approaches to west, and then yeah.
Correct, correct, correct.
Yeah.
Right, right.
I had asked my technical person also to join. He'll be there in the
Yeah,
session. One Mr. Chandu
I think
Mohan.
he's already there.
Yeah, might
Okay,
be. Yeah,
okay. Yeah, fine.
yeah. For your information, I just
Yeah,
passed the
Hi,
info.
hi, sir.
Hi, Chandu.
yeah,
Yeah,
yeah. I
right.
see Chandu. Yeah, yes.
Hi, hi,
Welcome,
hi.
Chandu sir, as
So
Hi,
well.
how many?
madam. Yeah, thank you so much, ma'am.
We are all
Uh,
set, ma'am, or how many we are expecting? Already
yes, so you were
29,
asking
I
something.
believe.
Yeah, actually, SE students have lecture till 4 o'clock.
Ah,
So once they finish, they'll
no
join.
problem. No
Yeah,
problem.
they have a maths lecture,
Okay.
and
Okay.
they'll join after they
Okay. Okay.
finish.
Yeah.
Because yeah, so we'll wait for 5 minutes. Otherwise, we'll start. They
No,
can later on.
no, no problem. Let's wait. It's all 30 only, no? So let's wait for at least half of the strength to join. No problem. We'll do.
Yes, yes, yeah. We are expecting
Yeah,
at
yeah.
least 60 or so. But once 40 students are there, we'll start.
Up to you. No problem.
Yeah, sure.
Yes, ma'am. Ma'am, I can share the screen for the introduction, and we can wait for 2-3 minutes more if needed. So I'll just start the presentation for the introduction purpose. Like rather than having
Yeah.
a blank screen, let's have the poster there.
Yes.
Yes, sure.
Yeah. Correct. I think we'll start because we have to finish on time. So that's I think we'll start because many students are saying they have a weak connectivity because of the rains in their native places where they are
Okay,
right
no
now.
problem. No problem.
They have some connectivity issues,
No
but
problem.
they'll get the recording afterwards. So I think we can start.
All right, all right.
Yeah.
We can.
Yeah. So Akshay,
Yes, ma'am.
you can start. Yeah.
Sure. Okay. Hello, everyone, and good evening, everyone, and welcome to the Color Week 2020. Today's day 3 of our session of a Color Week, and the topic for the day is basics of color management and process standardization by Das Damodaran sir. So yeah, before starting the session, I would like to announce the winners of yesterday's quiz winners. So first is Shubham Naikre from BE Printing. Second is Prajakta Nare from third year printing. Third is Ajit Rane from fourth year printing. Fourth is Shubhangi Chan from TE Printing, and fifth is Kostu from BE Printing. Congratulations to all the winners, and uh, I'll hope everyone will participate in quiz in more numbers and try to be in the top. So before starting the session, let's revise like what we learned in last 2 days. So on day one, Dr. Narendra Ganga Khedkar sir took the topic fundamentals of color science, and we talked about the tristimulus values, LAB values, then the various models of color systems. And in day two, it was taken by Mr. Ravi Vaidyanathan sir, and we talked about the transformation color. We discuss about the color profiles and various LAB systems and XY systems. So, yeah, before starting to this session, I'd like to thank Mr. Das Damodaran sir for attending the last two sessions. Like literally took out his time from the busy schedule and tried to join the session and attended the last two sessions. So, yeah, thank you, sir, for that. And
I didn't
now,
completely. I just had a glance. Okay.
sure, sir. So now I'd like to invite my friend and colleague Atharva Kulkarni from Take It Over from here and introduce our speaker.
Thank you, Akshay. It is my immense pleasure to introduce our today's speaker, Mr. Das Damodaran. He is the business head, Indian Operation Farb Technologies, Mumbai. Mr. Das Damodaran has done his BTech in printing technology from Calicut University Engineering Institute and then worked in a Indian Express in start of his career in the web and then with Schwak Chennai, the largest pre-media company globally. He is a thorough technician in all mode of print and packaging with hands-on experience in implementation of color management and process control system across India. And he is also certified as a color expert from Xrite and GMG. The company present GMG Color Germany, Xrite USA, Global Vision Canada, Ardin Software UK-based organization for package design building and die making and so on. He heads business development, sales and operation for Farb Technologies, the solution provided for almost all the domain of print media. Thank you, sir, for joining with us. Over to you, Akshay.
Sure. Thank you, Atharva, for introducing our speaker. Now, I would like to invite Sir Das Sir to take it from here and to start the session. I'll just stop sharing. Over to you, sir.
Thank you, Akshay. Thank you, Akshay, and Srikala ma'am for inviting. Real pleasure to have an opportunity to present something for PVG. Being a print engineer, I know the value of PVG among the print institutes in the continent or subcontinent, I'll say. I'll prefer to keep my video off for the moment. It can hamper the connection. Hope it's fine.
Yes, sir, no problem.
Yeah. Is the screen visible to all?
Yes.
Yep. Yep. So thanks for the opportunity again. I would like to have a glance on what all things as a company we do. We do color management, color measurement, file inspection, ink drawdown, setting up ink kitchen, ink dispensing units, die key line softwares, a lot of related products. So as of now, we are going to talk only about color. As I know, the last two sessions had covered a bit about sorry for the statement, they had covered about color, and I'm supposed to speak about color management and process standardization. I would like to give a glimpse of color theory and the standard vocabularies in the industry, as well as the units. Hope I am sure 90% of the concepts are familiar to you, but this is the base to talk on my slides. So I want each and every students to have a idea or a brush up of the concepts, so that whatever I am going to speak on color management might not be so surprising for them. Yeah. I'll take hardly 15 to 20 minutes to wind up the initial session. So I'll split the agenda as 3 or 4, and I prefer to make it interactive, or else we can split it like after my initial session I'll keep a break, and then we'll proceed to the color management, and then standard process standardization, and then finally the implementation concepts. And I had purposefully avoided the measuring devices concepts, the filters, those kind of things, because I had been through a web a flyer where you had mentioned it's going to present in another session in the coming days by some of my industry colleagues. So let's start in this. So what's color? Color is nothing but a feeling. It's like a smell or a taste or any of the feeling. And what all things are necessary to have this feel? We should have a light. We should have an object of what we are going to view, and we should have an observer. Right? If you are in a dark room, you can't see. If there is a peacock inside a dark room, you can't see. And if there is nothing inside a light, full of daylight or a D50 light or whatsoever, you can't. So these are the three inevitable factors to have the sense of color. So where it comes from, the history or the science behind color. Isaac Newton had discovered color by splitting the white light by using his prism experiment, which we all studied in our high school, late 9th, 10th. So splitting the light to a spectrum of colors ranges from violet to red. It's called the VIBGY or the rainbow colors. Out of this, what are we talking? Out of the entire light electromagnetic radiation, what are we talking? We are talking about a very small portion of the entire spectrum. We have heard of X-rays, gamma rays, UV, infrared, microwave, radio waves. Nothing. We are talking about, as a print engineer or as a human being, our visible light spectrum is this much only. Yes, the other electromagnetic radiations are useful for us in one or the other way, in terms of radio, in terms of transmission, in terms of medical diagnosis whatsoever. But as visible spectrum, we are talking about a very small wavelength, that is in nanometer, 380 to 750, and it generally covers it can be broadly classified as three: red, green, and blue. As if you combine them to three families, the entire spectrum. All right. So this is about color and what all theories are fiddling around in this concepts of color. There are two theories basically. One is called primary theory or additive theory, and the other one is called secondary theory or the subtractive theory, which you may be familiar. I'm just running through the basics, very basic concepts. So where these additive theories are more concerned. Additive theories are for light emitting devices, where a red, green, blue light sources can emit from a device. It can be a camera, it can be a picture tube of a TV. And what are the basic colors in this? Red, green, and blue. It says if we combine all these three, we will get white. If we combine the complementary colors, we will get the subtractive colors. Let's say green and blue will give you cyan, red and blue will give you magenta, green and red will give you yellow, which are the subtractive colors, which is a reflective part. The theory number two, subtractive color system, which as a print engineer, we are more concerned about this, where we are going to print on a opaque or a transparent substrate, and we are going to sense the color as a reflection only, right? So this phenomenon is subtractive color theory. Let's for example, this illustration gives how these process inks on a white paper gives that feel. A printed cyan ink film will absorb the red and reflect the green and the blue colors, and that's why this sensation is cyan. Similarly with magenta, it reflects the red and blue and absorbs green. So this complementary supplementary colors must be very clear for us to proceed further. So that is the only reason for explaining color theory in an illustrated way. All right, so we had finished off the color has a feel, sensation, the physics behind color, and the theories of the color, and what all the vocabularies in color, in our industry vocabularies. Basically, there is a hue, value, saturation. These are the main three words which you come across. The very design concepts or the graphic concepts of the color. These are the three attributes. So what all these three stands for? Hue is the name of the color. You name banana, it's on yellow. Hue, its hue is yellow. What is the value? Value is how dark it is, how light it is. The more ripened the banana, the more yellow it is. Otherwise, it's on the greener side, right? If it's on the ripened side, on the start of the ripen season, it's on the lighter note of value. And if it's too dark, it's going to be the darker note of value. What is the brilliant? What you call by brilliantness of a sample it's basically the dullness or the purity. A fresh tomato and which is kitchen for powerful week. So both are red. Both are intensity is same, value is same. So the saturation is basically the brilliance of the sample. So these are the basic vocabulary when you measure color, when you mention color, not measure color, sorry. I'll explain in a detailed way on this. So you can see yellow patches overall my screen, right? So it's been divided into vertically into 2 and horizontally into 5. So what is it? What is the combination? So my first yellow is yellow, pure yellow, and I'm adding on black from left to top. If you see the first portion only, what I'm doing, I'm adding value, I'm adding darkness in terms of small percentage. What about here? Same yellow, I'm adding a little bit of blue. There is cyan and magenta combination. So it's going to be on a bluer note than to be a grayer note if I go further. So this is the basic illustration to understand how you can relate this hue, saturation, and value when you call a color. I just made it lighter. So what does it mean? The depth of the yellow is reducing. That is the saturation. Then another vocabulary you must be familiar is tonal value increase. People call it as dot gain. People call it as dot areas, whatsoever. The actual terminology, as per the print science, is tonal value increase. It is. Hope you all know. No, we are going to print continuous tone in half tone by breaking the image to CMYK channels. So the half tone increase, the increase in the dot area from the original file to the play to the printed paper or film or corrugation board or signage whatsoever. That is the tonal value increase. Simply the dot gain. The left top gives you the nominal dot. The dark concentric circle is the dot, and this dotted, the gray mark is the increase, in representation for the increase of dot, that is the dot gain. And normal dot area, for example, normal dot area is 80%. I have a dot gain of 50. What is my press dot? It's 95. So it's as simple as accommodating the pressure, accommodating the porosity of the paper, your ink property, in the combination of ink and water behavior, the chemistry of. So it's basically the result of all these, and it's inevitable in the print, and it should be in a controlled way. We'll see how it is going to affect, how it's going to affect our print results and so on. An ideal dot gain curve should be like this. I'll tell you what is ideal and what is non-ideal on the later note. And another terminology in the industry can be density. What is density? Density is simply the ink film thickness. Ink film thickness on a board or on a film, any print media, which should be measured and monitored. I'll tell you the reason why later. And it should be measured on solid ink, 100%. A reason, the gradations, that 0 to 99% will have the effect of dot gain. If the press or the print reproduction system is not properly calibrated, it will dot gain also will accommodate for density. So ideally, solid ink film thickness should be measured and termed as density to monitor your press run. What is characterization? When you talk about color management, this terminology is inevitable. People will say characterization of my press is bad, characterization of my CTP system is bad, my engraving system is bad. What is it? It's nothing. It's basically method of collecting your spectral data from any device in a compensated tonal value curve. It's a compensation curve, or maybe you can say, the behavior of the entire print reproduction system includes paper, ink, and so on. And this is needed to make the color management system running. So this is the input of the color management system. Profile. That's also another name which is inevitable in terms of color management. What is profile? You can hear of any number of profiles. Name of profiles can be different. In-house profiles can be made by printer, by him. So what is profile? It's nothing but a file. What it does? It relates your press values, color values, to a independent system's color value. For example, if you are talking about a combination, CMY 2020, this profile will relate how this will behave in your press and how this is going to behave in an device independent color space. So what is color space? That is called, maybe can be termed as gamut. Color space is nothing but the ability of any device to reproduce colors, or the range of a device to reproduce color. All right. Generic representation of a gamut. So gamut is the ability, as I told, the ability of a device to reproduce color, ability of a device to print color. It not doesn't need to be ideally print. It can be a camera which can give a range of colors. It can be a human eye, give a range of colors. So that is the gamut, or maybe the and this is an example of showing how two gamuts are interrelated to make a profile, which can be explained a little later too. But I would like to show you this is the way it's represented in a 3D representation of gamuts. All right. So what about the vocabulary's been over, the basic theory's been over. How about the color units? How we can measure color? Everything have a unit to measure, right? If it's distance, it's meters or kilometers. If it's everything have many units to measure. Even miles is used to measure the distance from place to place. So color also have unit or couple of or 3 to 4 mode of measuring, and it's applied as you need it. So HSB, hue, saturation, brightness coordinates were defined in the very initial stages, and now also in some design-oriented softwares. Photoshop is an example, uh, which tells about pointing a color with 3 coordinates. So H is the hue, as you know, the name of the color, and as the saturation is the amount of the white, and B is the brightness. So this is almost related to what the initial topic we talked about, hue saturation value. And this ranges. Is there any question? What is it? Let the volume be. Yeah, sure, man. Sure.
Yeah.
Is the screen visible? Is the screen visible and audio volume is okay? You can speak, I think. Otherwise, I have to
Yes,
go
sir.
back. Yeah.
No,
Thanks for
sir. Yes,
pointing
it's
out,
fine. It's fine.
Padmaja ma'am. So we were talking about the HSV concepts, and H is measured in terms of angle 0 to 360, and the saturation and brightness is on a scale of 1 to 100 across. Might be familiar with this screen when you design something in Photoshop. So this is a unit which is confined to the design concepts still. Then comes the CIE LAB color space. We have two phases of evolution in 1931 and in 1976. Till now we industry usage is more into 1976 CIE formulas, and there are new formulas as 2000 and the CMC model for CIE LAB. What does it says? It says basically about measuring color with 3 coordinates, 3 perpendicular coordinates with L, A, and B. So L value is the lightness and darkness. Your 0 and 100, your black scale, it ranges from 0 to 100. A value is the scale between red and green, minus 127 to plus 127. B value is the scale across yellow and blue. So this is the it said that if you can name 3 coordinates of LAB color space, we can define a color, and it's an industry practice too. And any color in this Pantone book or in the process colors or in your artwork can be mentioned with LAB if you know these 3 values, and vice versa. It's easy to remember this LAB concepts. L indicates for sure everybody will remember the 0 to dark, 0 to black. A normally in my college days I used to remember this way. If apple is red, on the positive plus A is red, and B before banana, it's yellow, plus B is yellow, and its complementary colors, in the opposite colors are green and blue. This is the way I used to, remember in my college days, academic days. So are the two patches same? If you're seeing in a monitor, calibrated monitor, we could find a small difference. So what is the difference? There is these are same. Are these same? No, there is a difference. It have a slight variation in terms of L, in terms of A and B. So how do you calculate? This is the formula to calculate the difference in color. Difference in color is termed as delta E in industry, and it's the square root of difference of L, A, and B. Another color space, another unit to measure color called LCH color spaces. Basically, same. It's more or less related to LAB, but it's more having relation with the HSV concept, but on an evolved out to a more detailed rule. And we use both sometimes to correlate or to address issues in terms of print reproduction. LAB is more into a rectangular coordinate based concept. LCH is more into a cylindrical coordinate, where cylindrical coordinates of these three variables. See, L stands for lightness, as we know. C is chroma, and H is the hue. C is the dullness, and H is the value of the color, and it's in angle. Okay. If you point a color somewhere in the color space, so this is the color patch, the black. The distance with respect to the L axis is A, and B. These are the A value and B value. So how it can be related to C and H? Chroma is generally the difference from the center to the patch, and H is the angle of shift from red. Basically, it's tan theta of this P and A value. How we can compare these both units? As I said, these both are in industry practice. How we can compare these both? See, the L value is 54, 81, and 70. The value of the same in terms of LCH units are L can be the same. C is distance from the center. That should be in the hue is the angle made with the axis. So this is how we relate LAB and LCH. Why we need both of this? LAB is purely an arithmetic concept. It doesn't show if we are saying it's deviating. In LAB, if you are saying delta A of 2 plus 2, and we don't know where it is shifting. But with LCH, the angle of shift can be explained with H value. And generally, this ranges from 0 to 100 for L, and 0 to 100 for C, and 0 to 360 for H. Basically, side-by-side illustration of the two concepts of LAB and LCH. Any questions till now?
Yes, sir.
The lab values, yeah. So why it's in between? Sir, in the lab values of A and B is in between 127 to minus 127. Okay. Then why it's in between 127 and not 100?
I think he means that is 256 color ranges we have. So 0 count as 0, and 0 to plus 127, and 0 to minus 127. And he's asking why not 100 like L? If L is from 0 to 100, then from that perspective.
Basically, darkness and lightness doesn't have no nothing opposite in terms of either it is dark or it's entirely white. Whereas in the B and A axis, you have a opposite color. If it's plus B is on the
Right.
right, I mean positive axis, and it's minus B is on the green axis. Um, you have a range, right? And these are colors as I shown in the initial two theories. These two colors are what you can say opposite colors. It will not come in the family of yellow in that aspect. Otherwise, so why it's not? I don't find a reason for that actually.
Sir, can I say something?
Yes, please.
Is it related to the computer image that when we have a computer image, it has 0 to 256 shades, like whenever whichever color we are saying. So when we are talking about, so if we divide that in two, then it becomes 120 minus 127 to 0 to plus 127.
So this is basically to relate the three modes of measuring. The one is
Yeah.
HSB and LAB and LCH. If you are targeting, that's what your answer was, right? So if you want to relate, so otherwise one will be obsolete. All these three theories validates its own holds its own validation. Reason all are correct, and these applications can be different, and all these have a correlation. So we cannot accommodate if it's within 100. The range of colors.
Yes, sir.
Yeah. Any more questions? Or else I can start with the color management concepts.
No questions, sir. We can move ahead.
All right. So color management. So comes to color management. So we had covered the vocabularies and the units as well as the theories behind color. So let's come to color management. So why color management? Color management is that important. So what are we losing if you are not having color management in place for print reproduction? It's basically it said the brand owners who is going to affect if who is going to have a hit if the color is not reproduced well in package or maybe in any of the product package. It's the brand owners. So it's the product owner. Either can be a pharmaceutical brand or can be an automobile or can be an FMCG brand. They are going to have the hit. So brand owners had emphasized their color when you have design, when you have this concept in design mode, and any variation from their expectation can have the hit. Reason, when you go to a supermarket, if you don't know what a product to buy, I want some cosmetic fairness cream, but I don't know what brand I need to choose or what product I need to choose. Most of the decisions, 80% are because of the brand recognition and the color appeal of the particular product. In that way, color is so important for a buyer to buy something from a supermarket or from a online purchase or whatsoever. And how the consistency of these colors are important. If you had purchased something and used it for some time, and you have a awareness, yes, this product is good, this product can meet my expectation, and you're going to purchase it for the next time, and the same product have a different slight color variation, what we generally feel is like it's a counterfeit product, or it's like it's not the one. As a human tendency, human instinct to believe on that regard. So brands are gonna hit if our color reproduction is not as per the expected or as per the previous lots, or as per or not as per regionally. If you have a variation in terms of color, this is going to happen. So color is that important for any brand or brand buyer. This slide I normally kept it in my brand presentations. The reason it said that in humans, females and males have different perception. We males normally club most of the colors to 2 or 3 family and we'll see out of the Vibgyor spectrum. Like no red, I have if you have 3 or 4 variations of red, without a spectrophotometer, I won't able to identify sir. But it's said that in females there are more X chromosome, which determines your color vision, and you can find a more a range of products. So maybe that's the reason for the cosmetic products, nail polish or maybe the lipsticks kind of things have in a more range. And for us, for shirts or have a range of 3 or 4 family of colors only. So basically, and more of the shopping decisions are done by females. So if, color is that important for us to maintain throughout the supply chain. Some example for inconsistent between same products. As I told you, I'm buying tide from supermarket here and in Mumbai. It should look the same. Otherwise, I will not believe this tide is the same tide which I use in Kerala and I'll get the same result. So this is because of the production run differences. And let's say this is a typical example of a brand which have multiple products, and there will be one brand color. If you consider maybe Lifebuoy green or Lifebuoy red is throughout the same in sanitizer in terms of their bathing soap or in terms of hand wash. That should be the same. This example is typically different. Not Bertie Bees is a Italian brand, I believe. So brand color across different products, across different substrates are important. Otherwise, it loses the credibility of people's trust on you. Some example, see brand people knows this, and brand people maintain the colors as it is for many years. Starbucks had this logo in 1987, the first logo, and later on it evolved to a logo where the illustration changed, the artwork changed, but the color is the same. 2011 they changed it, again with illustration different. Concept is the same, but Pantone color is the same. As a color expert or our OEM companies think in 2040 it will just with the paint same Pantone. There are many other brands. Tiffany maintains the same color throughout, even if it is a mug or a cup as a gift or as a wrapper or their showroom itself. They paint it the same brand color. Airtel have a lot of evolution in terms of logo. They changed the logo illustrations, but the color is the same. L&T have many domains, but they maintain the same color. How it generally works? Why this color kind of variations are happening? We are seeing we have to maintain color same throughout the supply chain, and there are a lot of impacts financially in terms of supply chain, in terms of the purchase tendencies, in terms of having brand trust, competency, whatsoever, counterfeit. How it generally works? Why it's going to vary? If I'm giving the same artwork everywhere, why it's going to vary? Reason, the one artwork have to travel in different mode. Before becoming an artwork, it was in a camera, it was in a then it comes to a monitor, then it comes to a printer, which is a CMYK printer, which is a digital laser printer. Then it can, the same color can go to, same artwork can go to a different product, like an inner carton, like a pouch, like a mother carton, right? So it can go to another mode of print, a large format printer on an inkjet printer. So same color transform to many sources and many space. So there is no color space, interlinked color space for any of these. If that's the situation, yes, it's definitely going to vary, right? Typical example, I'm viewing a picture, a lady picture, smiling lady on with my eye. It's different. It's with a scanner, I scan it, it's different. On my calibrated monitor, uncalibrated monitor, sorry, it's different. Printer vision is, again, it's different. It's simply based somebody saying like speaking in 2 or 3 languages. Somebody from Maharashtra speaks in Marathi, saying this session on color management is scheduled on 4 o'clock. No, I understand this since I know Marathi. If I'm not knowing Marathi, somebody need to translate me, who understand my language and the other language. Somebody need to tell me in English, or otherwise I'll tell in Malayalam, in my home mother tongue. Okay, I am available at 3:45 or maybe 4:15. I'll be late for 15 minutes. So who is going to translate? There is no common color space. There is nothing. So somebody in between correlates both of our language, translates to our understandable language. No, it's a give and take kind of thing. Then yes, the concept is clear, and we could able to convey what I meant. So this is the same with color management. Okay, so how it can vary? What are the major variables in terms of color management? The three variants are the three variants in terms of the entire print production can be classified to primaries, white and black point, and the tone reproduction. So what is colorance? The printability or the range of the device to produce color. Camera, scanner, monitor, printer, another printer, different mode of print operation. So all have different range of colors. Ability to produce colors is different. So that is called the gamut. Basically, this is the colorant, first variable. So what is the next variable? It's the basically the white and black point. So what is white and black point? White point is basically the usually kind of more important about the having a substrate color, rightly defined substrate color. The color of your zero area in an image is the white point. What is the black point? How dark a color can go. That's a black point. Typical examples of artwork where the white point is defined are wrong. Incorrect white balance on the left side. My paper itself is little blue. My white point I have been defined it as towards blue or not. Maybe an optical brightened paper. Right side I had made it proper on a lower side. My white point is correct. So this is the color. And white point have a more impact on human eye when you see a color. Why? Because it takes that as a reference to judge the other colors. This is the black point. A difference with black point. So this a correct black point gives you the richness or gives you the contrast between these colors, and the incorrect black point is a washout feel. My darkness is not there, my richness of color is not there. So basically, what is the third thing is the tone reproduction curve. Basically, the relation between your input and output value. Your input can be a file on a plate maker, can be a file on a digital a gravure engraving system, and output is on a mostly on a substrate. So how it's defined, how it's how the relation is, my input and output is. It's basically it should be properly defined. If I know my 50 percentage is going to come as 70 percentage or not more than that, I have to keep the compensation correct in place for the prepress. So this is the third aspect. Normally it can be termed as gamma curve or dot gain curve as per the process. How to implement this? Okay, so we know about the color values. I mean the color theories. We know about the vocabulary of colors. We know about the importance of color. We know about how this can vary when I try to reproduce something in my print facility. How to how to implement this? Basically, there are four steps on implementing a color, implementing the CMS system, color management systems. Your monitor should be calibrated, well calibrated. It should be able to, view the file as on a D50 light source or a proper light source, and as on a press run on a particular media, n number of medias, I'll say. For that, what we have to do? You have to correct the three variables again, same, the white point, black point, and the output device is gamma curve. Similarly with a scanner as well as monitor. And comes standardization, the other concept what been included at the seminar topic, process standardization. So what is process standardization? How many processes are there? There are how many process of print, like offset, sheet fed and web, digital, n number of modes, of gravure, flexo. So what is process? These are process. These are my process. What is standardization? Each process have limits and benchmarks uh, for reproduction. So we have to be within that first. Then we talk about color management. So I had split the implementation slides into two. As how to implement CMS in general and how we should be familiar with the standardization part to make it standard first. So the major standards in industry are FOGRA, GRECOL, Japan, color, SWAP. So these are the major standardization, way of standardization. And the most predominant in our industry is GRECOL and FOGRA. GRECOL is achieving its emphasize or importance in terms of brand owners as well as printers in recent times. So I'm sure students will be familiar about these concepts. So what is FOGRA? What FOGRA says? FOGRA says you watch your dot gain, automatically gray will be done. What GRECOL says, the other way around. You watch your gray, your dot gain will be proper. Yes, of course, they have different families as well. Offset program, or basically termed as ISO standards. ISO 12647 is the standard for printing. It have six classifications where sheet fed offset, web offset, gravure, screen printing, flexo are defined. And what else are defined? FOGRA had defined 8 paper types on sheet fed, web offset, all mode of printing. So obvious PSO standards are there for gravure as well. Watch your gray before dot. This is a typical example of dot gain standardization and getting gray done. Watch this gray, black 50 on top and correspondent gray below. Before we could see that both the colors different, right? Once you standardize the dot gain, it will be the same. It should be the same ideally. What are the major steps for both of the standardization, FOGRA as well as GRECOL? Find out the right LAB for your primaries. We're talking about CMYK standardization. No Pantones will come into picture when you standardize. Pantone standardization is little different, and the dot gain curves for Pantones are also different. It's not Muradeus, it's basically SCTV curves, which is a latest add-on to the industry. I don't know whether we should talk about in detail. Maybe if someone asks raises a question on that regard, like we can explain on the query session. So we're talking about the standardization of CMYK with respect to defined print standards. So FOGRA as well as GRECOL says to find out your LAB from the installation chart, and then you compensate dot gain in FOGRA, and then you compensate gray balance in GRECOL. So what's installation chart? So this is basically this installation chart, which was quite popular among machine engineers to color management experts to graphic designers in the industry. Basically, this chart will give you exact idea how my machine behaves on a particular paper, how my CTPs are linear or not, how my trapping properties are. So when you print this in the machine, this alignment is very specific reason. The head to gripper have same patches, same grids on top and below. You can identify how my ink is distributed from head to gripper. And left to right, you can see triangles. Let's consider black. Black have a bigger area on the left and smaller, it goes on tapering till the right. If while printing this ink starvation chart, you feed equal amount of ink throughout the inkies. Okay, and you will get linearly varying density from right to left. If your roller settings are okay, your ink distribution is okay, whatsoever. Reason, you have a bigger image area and you are giving same ink throughout. You are a smaller image area on right, you are giving equal amount of ink. So density will be more from left to right. So this is the concept, and based on this, we measure all the 1 to 14 keys in a particular software or with a standalone spectrophotometer, and you put it in, you feed it in an Excel or in a software, these values. If it's in software, it will automatically give pop-up. LABs are defined in the software for a particular standard, either FOGRA or Greco. It will show you, yes, 8th key of cyan is having minimal delta E deviation in terms of LAB. I'm not measuring density with the spectrophotometer, I'm measuring the LAB, which is mentioned in the standard FOGRA or Greco. No densities are mentioned anywhere as standard. That depends completely on the ink you use or the paper you use. No, so this gives a right LAB, right densities at optimal LABs. No, it's a correlated kind of. So LABs are defined, densities are nowhere defined. If you hit the LAB, it will give you a pop-up. Yeah, this is the density with this ink and combination. And we measure the dot gain of those ink keys where the LABs are passing. Okay, so this can be the dot gains of 5 of the entire spectrum, which range the initial quarter up to quarter tone. You measure three values, maybe 5, 10, and 25, 70, 50, 40, 60, 40, 50, and 60 for midtones, and 75, 95 to the darker tones, and you plot it in a graph. And dot gains are also mentioned in FOGRA. This I'm talking about FOGRA, not Greco. And in Greco, only the LABs of grays are mentioned. Then LABs of gray, no dot gains are mentioned. So you standardize using a different chart called P2P chart. Okay. So this is all about the standardization concept. LABs are mentioned. Paper LABs for CMYKs are mentioned. LABs for overprint colors, secondary colors, that is RGB, are mentioned. When you the trappings are mentioned. The primary value of 8 paper types are mentioned. In FOGRA, the similar with Greco, only the difference is the quarter tone gray, mid-tone gray, and the 3/4 gray are mentioned in Greco, whereas it's the dot gain in FOGRA. So this is prerequisite for color management. Standardized process, standardized for color management. Then comes the color management thing, charts and all. So once this is standardized, why we need color management? You are going to print on a lot of papers, right? You are not going to print on 8 paper types only. You are going to print on paper types which doesn't falls into these categories. And if you want to get similar colors on all papers, or at least matching colors, it should not be XY, it should be X plus and X minus. What do you have to do? You have to do the color management, and you have to have a prediction of these colors of your print process in the pre-press stage. You should have a proofing system, right? You should have a small digital printer which should be able to predict your results in the pre-press. So how you do it? That's color management. You get the similar colors on most of the paper types you use. That is color management. Okay. You get similar mockups done as similar mockups on digital eco-solvent printers or UV printers. What you need is the color management. So how you get it? You select your first test chart first. These are the international test charts, internationally available test charts, which can be used for color management. ECI, IT8, and Flexo. What are the difference out of 3? Different in terms of number of patches. How you select your color, how you select your test chart depends on what is your aim. or how complicated is your print process. You know, if you if you have a lot of issues with your highlights, you should use, or if you have a lot of issues with the entire print fulcrum, you have to use a very detailed chart. It's basically like a Google map. When you want to go from Pune to Ahmedabad, if your road is one road, you can put one stretch, the destination and your starting point. Or otherwise, Google Map will show you, n number of points where you want to take a left, where you want to take a right. So it's basically similar. More number of measurements, you are more clear about your path. How to capture this data after your fingerprint? How to capture with this? There are devices, spectrophotometers, densitometers, plate dot meters. I didn't included the cylinder measuring or the sleeve measuring devices as well. That also to be a part of this measurement. I hope it's clear till now. We have another small session on how the profiles are made, and
Yes, sir.
Hello. Can I proceed, ma'am?
Yes, sir. Yes, there are no questions as
Yeah.
such. But yeah, students, if you have any questions,
And time, yeah, make it interactive. Otherwise, I also feel bored. And like time's also up. Maybe if anybody have a rush, let me know. We have another 15 minutes more. I believe we started a bit late.
yeah. No, we'll finish whatever we have decided. No problem with that. But
All right.
some questions are coming up. So you want to answer it now or later on we'll answer?
Anyway, fine. Better. What is the role of tone reproduction curve in any process? Sir, for ECG, what is the SCTV specification for OGV? Great. Okay. For the first question, what is the role of tone reproduction in any process? See, every process, let's consider one process. I'm putting on an offset sheet-fed machine on an art paper. The dot gains are inevitable. It will have dot gain, right? So we have specified limits of the dot gains. Let's say 50 can come like 65, or maybe for 50% dot, and 40 can come like 14% whatsoever. We have to limit within this reason. Otherwise, your half tone will look closed. And if you try to reduce that closeness, your solid will look pale. So that is the importance of tone reproduction curve. Tone reproduction curve can be split into two parts. In prepress, maybe in a CTP, they should linearize their plate. That is 50% on your file should be 50 on your plate. If it's coming 60, they have to apply another curve there for that particular device. So that is also a curve. So I'm not very clear on what kind of curve you ask for. If it's a dot gain curve, my first point was the answer. If it's a plate linearity curve, this is the answer. Atharva. Is it clear? Sir, for ECG printing, what are the SCTV specifications? So SCTV specifications are the SCTV is basically it's a linearizing concept. See, end of the day, the reason for evolution of SCTV is and CM/K can hold the same dot gain value for all the 4 channels in terms of dot gain. But if you compare Pantone, reflex blue, which is a high contrast color, can have a dot gain up to maybe 20% in 50, whereas a cool Pantone, let's say cool gray, which is a low contrast color, can't have that kind of dot gain. So that is the reason for of the need of a different this thing dot gain rule, and that is the reason for evolution of SCTV, right? Extended gamut you can apply Murray-Davis for CMYK, and the OGV will have SCTV. Orange, Pantone green, and Pantone violet have a dot gain in SCTV that should be applied for OGV dot gain compensation in AECG. Projecta, yeah, is it okay? Is it that you meant? How the dot gains are calculated for non-CMYK such as OGV? Okay. With the help of SCTV database curve, for which you have to use a software which is capable of accommodating SCTV curve. Maybe for ESCO, GMG have it in proofing, ESCO have it in RIP, measure color, or some other softwares. Which charts are used for printing CMYK OGV? Those are custom charts, Pratmesh. Depends on the process, which is a combination of CMYK OGV. The proprietary formats depends on the ECG softwares you use. Yep. Can I go back to the presentation? No more questions,
Yes, sir.
are there?
Yeah.
Yeah.
Yes, sir.
So we are done with the test chart creation, test chart printing, and evaluation of the test charts, and we have to understand what mode of profile I have to create, and what are the industry available profiles, and how I can correlate with. What is a profile? I told you before. It's just a file which can correlate your color space and a third-party color space, which is independent of machine. Basically, these are the three things: content of the profile, ability of gamut, ability of a device to produce colors, range, the white and black point, and the tonal reproduction. So there are two basic way of profiling. One is device link, and the other is IGC. Can be said as device dependent and device independent profiles as well. Depends on the nomenclature what you call for. And device link is a way of operating, way of profiling, where it can directly correlate your CMYK value to another color space CMYK. There is no need of intermediate color space. No, the profile connection space PCS kind of concept doesn't need. If you are giving a CMYK value to a device link profile, let's say CMYK of let's say 10 10 10 each, and asking to convert it to another color space which is of newspaper. We are giving a sheet fed offset art paper standard and asking to convert to a call set newspaper standard. Device link doesn't need an intermediate color space. It can directly convert to newspaper color space. Maybe there is 10 10 10 for all. For the destination color space, it can be 11 12 13 14, depends on the behavior of that print process with the particular media at all. This is device link. This is dependent on the device, and it knows your device and the destination color space very detailed. And ICC profile are need some intermediate color space, so it converts this CMYK to a LAB, the 3 coordinate axis, then to a 4 coordinate axis, and it's widely used till design, not to production. And device links are widely used for production. Reason: this is an original file on the left side, right. First middle one is the ICC converted and device link converted on the entire right. No? So you can see the channel loss or the dullness or the data deterioration when you convert. This is like 4 coordinate, 3 coordinate, again 4 coordinate. So some data loss can happen in two mode of conversion. Again, an example of single black ICC and with device link. So this is the base concept about ICC and device link. Device link can be proprietary, n number of proprietary formats are there. ICC is the generic thing. You can have it down, same ICC can be applied to any interface or software is used, but device links are not like that. I'll go to the last concept of UCR and GCR, which is a very, very old concept, but used in different range in the software of the print. So what is UCR? UCR is nothing but both are UCR and GCR must be applied together to get right or the desired result. UCR is the technique of reducing your CMY on the darker tone. It's undercolor removal. Okay, and GCR is on contrary is the gray color replacement. Both are same, but both are similar, but not same. Let's say you have an example of basil green. Basil green, you have, if you apply UCR, what happens? Green, sand, magenta, yellow, and some black will be there, right? It removes the unnecessary black in CMY. And what it gives purity for the black. It gives a richness for the entire image. What GCR does, it removes the gray component and add to black. The replacement and removal, the terminology itself holds the explanation. All right. What is the strength of UCR? It gives a proper control for black. Good reproduction, more pleasing, flesh tone, skin tone, kind of saturation will be better. What about GCR? Gray is easy to achieve. In any print process, gray is quite unstable part, and ranges from 40 mid-tone area to let's say 60-65. If you apply GCR, there won't be much of image in CMY, and it will be carved out to black in the midtones. That will use control and it will use set off. It will increase the ink water balance. Reason you have to control all the 4 channels without GCR. With GCR, you can have minimal control on CMY. Reason there is no less image, less water, less ink, more control. Not talking about only offset, it applies for the other mode of printing as well. CMY without GCR, and the right side is with the GCR. You can see the difference of and generally it gives a 20% reduction, and end of the day it's cost saving. And optimization, faster running, drying time, make readies are better. You can keep richer tones rich by keeping the half tones undisturbed if you're applying a GCR concept in the production process. So this is all about GCR benefits as well as concept. I'm almost done with my session. Any doubts? Do you want any more detailed explanation of any of this concept other than the what do you mean by overplayed black and how it is controlled? See, this is a pre-press concept, not comes under a color management concept anyway. See, overprint black is something you have a what you can say text when you design. You can have a text on top of a screen Okay, with you remove the background below the text, and you can keep the text on that black text on top of that screen, let's say scan screen. But when you have a light misregistration, that white area will be visible in the press run. But if it with a continuous this thing, the screen will be erased and will go text go on top of, and you have a, is what you mean, Akshay, or is it anything related to the trapping or the tackiness of the ink?
Akshay, can you unmute yourself and
Hello.
ask?
Sir, your voice was breaking. Sir, can you repeat what you said, like about trapping?
I was, so your question was on trapping. Your question was on overprint and knockout.
Sir, I was talking about the trapping thing.
No, I was saying it can, we were talking about the question. If it's of overprint and knockout, I explained. If it's for tapping or the tackiness of the ink, it's different. So I'm asking, is it related
Yeah.
to the tackiness or the trapping, or is it related to the overprint and the knockout?
So the overprint of the knockout thing.
So is it clear? Is my explanation suffice?
Yes, sir. Yes, sir. Yes, sir.
Yeah.
So when to apply any specific image that you apply UCR, GCR, or it is just
UCR is normally applied for a darker image, ma'am.
okay.
And GCR can apply for any image. Why? Because it doesn't remove any color. It just replaces. If it's in UCR, it removes undertone colors, and results can be other way around as well. On a red tone, if you apply UCR, even though CMY are like three colors can be there, and it can turn to orange as well. It can turn little lighter, and generally UCR are applied using device link profile in combination with GCR now,
Okay.
because of these kind of issues. My screen is visible.
Yes, it is.
Is my screen visible to you? All right.
Yes, sir.
One second. I had opened 3 PDFs.
No, those are not visible. I think you have just shared the Chrome window
Okay,
and
okay.
not the entire screen.
All right, all right. So I should stop sharing and I'll entire screen. Okay. So okay, and the right side is a UCR treated file, and the left side is the GCR file.
So we are not
I'll
seeing
show the. Is it okay?
Yeah, now it is okay.
Visible now?
Yes, yes.
Maybe okay. Yeah. So I was saying the middle one is the original. Right side is the UCR, and the left side is the GCR file. Okay.
Right.
I'll just show what is UCR and what is saying in terms of a practical application. You see this? Okay, one second. See this? Entire left. CMY.
Yes.
The middle one original, and the right one is UCR, and the left one is the GCR. It did removed some undercolors for the right pick, remove the colors.
Sir, your
Similarly
voice
with
is breaking actually.
GCR as well. Is it? Hello?
Yeah.
Hello?
Hello.
Audible?
Yeah.
Interrupt me if I'm not audible. My coverage is also going a little less.
Yeah. 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 So if
I'll show you the
I
black
close,
channels first.
yeah. Oh,
This
right.
in the right one, you have everything on. It just removes the undercolor. Everything to the back. Then replace it.
Sir, the
Right.
voice is breaking.
Still? Okay.
Yeah, like it's a little bit
Hello?
of break in there. Yeah, sir. It's fine now.
Is it okay
Yes.
now?
Yes, sir.
Okay.
Yes, sir. Okay,
GCR.
it's not okay, I guess. It's still breaking.
Oh my. Hold on for a while. Hold on for a while.
Yes, sir, sure.
Yeah. Students, meanwhile, if you have any questions, keep writing it here so that we can try to answer some of those.
Yeah. How's it? How's it now? Audible? Hello?
Yes, sir, it's clear now. It's clear now.
All right.
Fine.
Yeah.
It's fine.
So I was just saying about difference with GCR. Middle is the original image and the right is the UCI and left is the GCR treated. And I have been showing only the black channel here. So I'll show you the CM. Well, I showed on them. So see, there is no difference in terms of black when you apply UCR. But when you apply GCR, the gray been replaced here in the black channel. Okay. So that's the basic difference between UCR and GCR. And when to apply UCR, you have to know what is your hue. If
Okay.
I am having a red color and I'm planning to remove the undercolor, and if I'm removing little more magenta, my hue goes for a toss.
Correct.
And I'll show the C. And basically, this is not done properly in many of the prevailing softwares. Sorry to say, and I'll say again it will be marketing. So this is the CMY. So the right side is the UCR where you are removing. That is the undertone. On the left side, GCR will have a extended UCR for sure. Otherwise, you can't show result. Concept. Reason I'm using an industry software to do that. If you're doing it in a Photoshop, something you will be more honest. So this is about
Yes.
of
Yes, sir.
Any more questions in the chat window? What is that? Please. Okay. What do you mean by okay?
What from that? I think they're done. Yeah. Any questions, students? So when you are profiling, see if you are measuring that chart,
Yeah.
so is it
Yes.
must to measure all the patches for the profile, or you can just take some 100 patches out of that 1500 patches and then plot the profile?
That entirely depends on the how complex the print run is.
Okay.
If you're printing on
Okay.
so you have to go for a bigger chart and you need to measure the entire pages.
Okay. Okay.
Decided somewhere in the software you can't do partial measurement and proceed. It won't plot the gamut. It won't plot the entire gamut. But
Right.
before you decide the test set, you can decide on a lesser number of patches or higher number of patches or medium number of patches. But entirely depends on the how complex my print run is. If it's in a flexo, you will have more complexity in terms of highlight dot gains. If it's
Right.
an offset, it is more or less okay. If regular or they will have dot loss because of the sunken etched cells. You apply dot gamma correction to boost it up, then you print it, and ink adhesion is a problem. So better to go for bigger charts in flexible packaging. Yeah, and in corrugation as well. The normal offset on an art paper, on a matte or a map litho, sunshine, good map lithos, no need of for a bigger charts. Yeah.
Right. Right. And for the delta E calculation as well, like if I'm having a process standardization thing, like I did one test before the standardization and after the standardization. So just for to check the delta E, so do I have to measure all again 1500 charts or 25, 50 patches
No,
will
ma'am.
be good enough to?
For process standardization, those three charts which I had shown doesn't comes in picture. For process standardization, it's either solids, overprints, and dot gains.
Right.
Okay. And to check the gray, you have to print the entire P2P chart.
Yes. Okay. Correct.
If you want to check the gray, otherwise people can't print this chart in once in a month and all. So what they do, they put a control strip where you can measure your standard dot gains. Standard dot gains in the sense 5, 25, 40, 50, 60, 75, 95. 5 or 6 patch will do the job. And for solids, CMY case, what are my primaries? And gray, quarter tone gray. Yeah. So that is basically the check mark. When you do the entire standardization, you have to print the entire chart. But when you want to cross check in between, you don't need to. Yeah.
Right.
And filters are important. When you measure something, the filters are important. When you measure a optical OBA media, you have to use M1 filter. There are 4 modes of filters. M0 is zero filter, M1 is the optical brightening filter, M2 and M3. So that will be a bit more detailed session. I'm sure tomorrow's session is about this, I believe. So you can have a better clarity on that. That is also taken into account. Should be taken into account when you profile or finger standardize. And standardization is different and color management is different. I try to distinguish in the possible way I can. I hope it's clear.
Yes.
Yeah, and it's a prerequisite for color management. Process standardization should be in place for a printer to go for standardization.
Okay. Okay. Correct. Yeah. Okay. So students, if you have any questions.
Hello, Mr. Damodaran.
Yes, sir.
Yes, Akshay sir.
Yes. Just I want to continue to what Srikala madam has said. I think the test chart which has been there, maybe TC167 or IT8 7.4. I think these particular test charts are exclusively meant for profiling purpose, correct? And for the measurement for the solids and overprints, I think we have different maybe test charts, maybe custom test chart. I think that is we cannot select at random patches from the test charts of 16, 17 or IT8 for measurement of these.
Yeah, that can be any custom chart which can accommodate your along with your print run.
Exactly.
Yeah.
And the position of that particular patches is very important in the test form.
Exactly. Position should be in the real direction if it's in a flexible packaging, or it's in the head to gripper. This thing, the test forms, the IT, TCA or flexo charts, which I had mentioned, and the patches. It's normally people put it as the color bar, the density control bar.
Correct. Yeah. And one question which I wanted to ask, that when we talk about this fingerprinting run, especially when we talk about implementation of ECG on a narrow wave flexo, so then those we also have any P2P chart with the help of CMYK OGV where we do it.
No,
so
P2P
any test charts
won't be. P2P or Grecol P2P or the Fogra charts are only for the CMY case. There won't be any OGV. I believe Grecol have some updation. I believe. I'm not very sure on that. Fogra anyway don't have. but Greco has
Yes.
some application for ECG. Yes, but narrow web again, the size space limitations are a challenge. How to accommodate that you have to see.
Because of which I think the P2P chart for CMYK OGB, just like a P2P, it's not exactly P2P, but how we have
Okay.
for that Idea Alliance P2P, no, for
Yeah.
Recall. So in the
Yeah.
similar way, I think for fingerprinting run we have CMYK OGB
We
test
have
chart.
mini strip. See, I'm not talking about on a product base. If you're talking about basically, I represent GMG. If you're familiar with our company,
Yeah,
GMG color management system. So we have
yeah.
a mini. We have something called mini strip, which can
Okay.
accommodate narrow web, or it's hardly 3 centimeter wide and 28 centimeter long. And
Can you show? Is it possible to show?
sure, sure. Why not? Why not? Why not? Hmm. Is it visible now?
Yeah,
Screen
yeah,
is visible, right?
yeah.
This is the one. And it's not one chart going to determine. It is, see, CMYK and OGB. Hello.
Yeah, yeah. I can see that.
Yeah. Yeah. This is the chart which we keep, let's say, for 8 or 10 number of recurring jobs. We understand how the pressure or how the ink distribution is. Then we take into profiling.
Now, when you do the fingerprinting with the help of CMYK OGB, so you match your
Yeah.
CMYK with the help of your Grecol specification, for example. Then for OGB, you go with the U
No,
and the
no,
chroma
no, no.
value.
No, basically, when you do fingerprinting for CMYK, depends on the ink manufacturer. They will have extended series. If you are talking about Flint or Siegwerk, they have their extended series.
Yes.
So we follow that LAB, and it's only if you and for orange, green, violet, as we have our own LABs. I'll show you that as well. That's not this thing. That's not the Grecol values. Oh bullshit! 1 second. That is within our database. Within our no, our profiling engine is a little different. Spectral based profile engine, not the LAB based. This is almost similar to offset is almost similar to your Fogra, and the OGB is almost similar to the Pantone plus coated series for offset. For Gravio, it will be interrelated with Backspace and the extended series. Yeah. And it entirely depends on if you are following something different than the ink manufacturer, the blending won't happen properly. End of the day, it's a monopigmented ink. Your trapping won't be proper if the
Correct.
primaries are different.
Okay.
Yeah.
Thank you.
Thank you, sir.
Okay, Akshay.
Yes, sir. So yeah, any more doubts, friends?
Can write to me in any case, if not highlighted in your mind as of now.
Sure, sir. Sure, sir. Okay, so now I'd like to call our faculty member Shubham Kharaj sir to share his view for the session and the feedback.
All right. Sure.
Yes.
Hi everyone, good evening. Am I audible to all?
Yes, sir.
First of all, I'd like
Yes,
to thank Mr. Damodaran and his colleague, Mr.
Chandu Mohan.
Chandan. Yes, Mr. Chandu. So thank you for being us and that you shared your knowledge with our students. That was really grateful. the knowledge, the information what you shared with us, with the students also. That was very uh, that was very unique and different than the color that what they are learning in their syllabus. And that I hope
Thank
it,
you.
all students have attended or heard this session very carefully. Hope they will understood what you, they have understood what you have taught them. It was nice overall. The session was very nice. Thank you so much, sir. And
Thank
over to
you.
you, Akshay. Thank you.
Yes, sir. Thank you, Shubham sir, for sharing your thoughts. Now I'd like to invite our my friend Ruget Upadhyay to give the vote of thanks. Ruget, over to you.
Yes, I'm audible. Akshay, am I audible? Hello.
Yes,
Yes, you are.
yes. You are audible.
Yes. So first of all, as Kharat sir said, I would like to thank our today's speaker and guest, Mr. Das Damodaran, for spending his valuable time with us and giving us great information about the basics of color management and process standardization. It was an immense pleasure for having you here, sir. Thank you. I would also like to thank Professor Madhura Mahajan ma'am and Professor Kanade ma'am for conducting this great session. I would like to thank Atharva Kulkarni for beautifully introducing Das sir. Thank you Subhangi Chauhan and Vijay Jadhav for the great poster of today's session. Thank you Aditya Huge, Pranali Kataria and Ajay Bankar for the feedback forms and today's quiz. I would like to thank Professor Shubham Kharat sir for giving precious feedback about today's lecture. I would like to thank Gargi, Riya, Pranit and Pratik for the report. And last but not the least, today's moderator. Thank you, Akshay Ingaye, for moderating this great session. It was really a great session. Thank you, everyone, for your hard work. It was a great session. Thank you. I now declare the session as over.
Thank you, everyone. Thank you. Thanks for the time.
Yeah.
Bye.
Yes. Thank you, sir.
Thank you,
And
ma'am.
Akshay will get in touch with you with the lecture recording and everything once he has.
All right. I
the
did share
recording.
the presentation with Akshay. Maybe you
Okay.
can talk to
Yes,
him
sir.
if the team wants. Yeah.
Okay.
Thanks
Is
for a
it okay
well-organized session.
if he
Sorry.
shares with his other students? Is it okay if he
No
shares that
problem.
with
No
other?
problem. I
Yeah?
didn't keep anything, confidential. These are the generic things which I had shared. Whatever I presented.
Okay.
Yeah.
We look forward to have your session in future as well, sir. Hopefully in person, when and if time permits.
My pleasure, ma'am. My
After
pleasure.
the
We'll
COVID
be
is
in
over.
touch. We'll be in
Sure.
touch. Yeah.
Yes, sir.
Thank you. Thank you, Akshay. Thanks for the coordination. Thank you, ma'am. Thanks all.
Thanks. And if you have time, sir, do join for tomorrow's and Fridays and Saturdays
I will.
lecture as
I
well.
will. I will. I will. I just want to have a glance on how it's going. That's the
Yes.
reason. I should not be bad, right? So that's the
No
reason.
problem.
Last day's
No.
join. I'll try to join for the upcoming sessions too, ma'am. Yep.
Yes, sir. Yes, sir. It will be a pleasure, sir.
Thank you very much. Thank
Okay.
you. Akshay.
Thank you,
Thank
sir.
you
Have a
very
good
much.
evening.
Bye.
Sure,
Bye.
sir.
Yes. Thank you. Bye.
Thank you, sir. Have a great day.
Evening.
Okay, great evening. Thank you, everyone. The quiz will be shared in your group. Do take your time, and it will be shared at 7:30 p.m. So check the quiz and give your best. And the feedback form will also be shared. So yeah, fill that form and share with us. Thank you, everyone,
It is in
and
the
have a
comment section.
great evening.
Yeah. Please leave.
Yeah.
We cannot remove anybody.